Well, we've so far been using mainly one coordinate system, but as a hobbit might say, we've had one coordinate system, yes, but what about a second coordinate system? So that's our goal for today, to talk about a different coordinate system. They might say, why? Don't we have one? Isn't one enough? And the answer is, well, it is, but there can be advantages to having a different coordinate system. So let's begin. So let's talk about the coordinate system we're most familiar with, which is Cartesian coordinates. It's named after René Descartes, who was a sort of philosopher, mathematician. And how does it work? Well, we kind of know how it works, right? You have an x coordinate and a y coordinate. So you're like, well, okay, so here's a point somewhere out here, x comma y. Well, what does it mean, though? Well, what the idea was, the legend at least, is René Descartes was one day sick and laying in bed. And this was back before they had Xbox. So there wasn't a lot to do. So as he was laying there, he looked up at the ceiling and he saw there was a fly up there. And he thought to himself, if I keep track of how close the fly is to that wall and how close the fly is to that wall, I can tell you where the fly is, exactly. So in other words, by keeping track of two distances, I know where things are. So what happens is we have a central point, the origin, and we have two directions. We call them the x direction and the y direction, and we move over some number of units x in the x direction, and we move up some number of units y in the y direction. So the xy tells us how far to move in each direction. And then we have what we need. So in particular, our location is a distance and a distance. All right, well, how else could we describe location? Well, there's another way to do it. And the one we're going to use is called polar. Now, you probably are familiar with polar, at least you've seen it if you watched a lot of movies. And there's something called radar. You see this, for example, in planes or more especially on boats. And the idea of radar is you have this sort of sweeping indicator that goes around and it'll do a little beep and you see a little light pop up. Beep, beep, beep. And what the light indicates is like, there's something interesting in that direction. And not only is it in that direction, but I can tell you how far it is. And so what's happening is it's saying, we're going to describe everything in location to the center, where we're at. And we're going to do it by saying, what direction do you need to go in? And how far do you need to go? So, in polar coordinates, it's a combination of direction and distance, sort of a different thing here. So, we have a point. Okay, maybe our point's over here. What do? Well, we have to talk about our direction. So we have sort of a fixed direction. It would be the equivalent of what's the positive x-axis, and we call that 0. And then we rotate some angle theta, and then we go out some direction r. So in other words, there's two actions. There's this sort of pivoting action to have us face in the right direction, and then there's a moving forward action to have us go the correct distance. And there we go. Now, I can describe every point by a combination of these two values, angle and distance. And so I have a different coordinate system. Now, here's something to keep in mind. When we talk about Cartesian coordinates versus polar coordinates, it's not like, oh, over here's this Cartesian plane and over here's this polar plane. That's not what we have. We have one plane. It's always the same space. What's changing is not the space, but how we're describing our space. So we still have our same geometry that's in the background. So that's an important thing to keep in mind. Our geometry hasn't changed. The way we describe things, that's what's been changed. Now, we have two coordinate systems. How can we get back and forth between them? So that's the next thing. What we can do is we can simply, essentially, lay them on top of each other. And so we say, look, here's the point we're after. It's 1 point. And now I just say, well, there's the Cartesian, which has x and y, and then there's the polar, which has theta and r. And we say, aha, look, what do we see? It's a triangle. But not just any triangle, it's the right kind of triangle. And so we say, perfect, perfect. Now we can start doing our various facts. So for example, Pythagorean theorem, x squared plus y squared equals r squared. Okay, so that tells us if we know what x and y is, we can get r. Okay, well, what are some other things? Well, we have trigonometry, right? So you have an angle, so you can say, well, let's think about the adjacent and the hypotenuse. So that's related by cosine. Cosine theta is x over r. Well, that becomes x equals r cosine theta. Sine theta, y over r. Y equals r sine theta. And tangent theta is y over x. Okay, so just write out y over x equals tangent theta. And therefore, we have these different relationships. You give me an r and theta, hey, I can tell you what x and y are. No problem. I have this rule. You give me x and y, I can tell you r, and I can almost tell you theta. Now you're probably like, whoa, what? Almost? What's going on here? There's a little bit of you have to be a little bit careful because there's a small catch. So if I have y and x, certainly I can compute tangent theta. That's no problem. And then I can say, well, take the arctangent, and that gives me an angle. But as we all know, because of our deep love for arctangent doesn't go for a full revolution. It only goes, a half a revolution goes from negative pi halves to positive pi halves. And that's it. So you have to do sort of a quick check. If you're over here on the right-hand side, where you're between negative pi halves and positive pi halves for theta, remember, theta equals 0 is this direction. So pi halves is straight up. So negative pi halves is straight down. So negative pi halves to pi halves is the right hand. So if you're in the right hand, then you're done. Just take arctangent y over x. If you're in the left hand, well, you still take arctangent y over x, but then you added half a revolution. So maybe it's pi, maybe it's 180. It just depends what your coordinate system you're using. Okay, one more note, and that is the following. We're used to the Cartesian coordinate system, which says, look, if I have this point here, there's just one way to describe it. There's one x, y, and that's it. And we're done. In polar, it gets more interesting. Now, you can certainly say it's unique if you add some assumptions. For instance, you say, I'm only going to let theta go from 0 up to 2 pi. I'm only going to assume r is greater than or equal to 0. Then essentially you have uniqueness. But there are some things that can happen. So what's an example? Well, one thing you can do is you can say, if I have a point here, so here's my point, and I have an angle theta and a distance r, well, what I can do is I can do an extra spin around. And that's theta plus 2 pi. But if I do a theta plus 2 pi, I'll be back facing the same direction. Probably a little bit dizzier, but I'll be in the same direction, and so I can move out the same distance r. Now, the more interesting thing that can happen, and this, of course, is maybe a little bit more confusing, is you can say, well, look, what can happen here? You have r, you have theta, and now you go out half a revolution more. So what happens? Well, now you're not facing that way, you're facing back that way, the wrong way. Well, what do? Well, you just start backpedaling. So instead of walking forward a distance of r, you walk backwards a distance of r. And so you could say, well, look, I'll go theta plus pi and negative r is equivalent to going theta and positive r. I will say there's one more note I do want to make. In Cartesian, we're so used to it, we will have our convenient notation x comma y. There's not really a standard notation where we do like theta comma r. So we'll just say angle equals theta, radius equals r. And we're not going to be like, oh, some sort of funny looking brackets or anything. We don't have that. Just on a side note. All right, so now we have our new coordinate system. So we should start by doing a little bit of exploration. How do we describe things? How can we convert from one coordinate system to another coordinate system? And in the next few sessions, we're going to get a little bit more in depth. How do we plot things? And then, of course, how do we do some calculus of things? It's going to be a lot of fun, so keep coming back. But for now, let's go do some practice.